In the realm of science and profound inquiries, the subject of what existed before the immense cosmic event has sparked mixed discussions and captivated minds for centuries. This monumental question does not only test how we understand the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the infinite void, and pondering what lay there before our universe was conceived. The event known as the Big Bang marked the beginning of history, space, and everything we know. Yet, was there a moment before this grand beginning? Could there have been a state of nothingness, a silence before the cosmic symphony began? And if so, what was it? Or perhaps there was something even more mysterious, existing before time itself. As we delve into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our comprehension. Physicist Brian Cox, renowned for his insights into the wonders of the universe, suggests that something extraordinary might have existed before the Big Bang. He challenges us to rethink our understanding of the material world and existence itself. In this exploration, we'll examine the science theories and enigmatic mysteries that could explain what existed before it all. We'll explore concepts like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered may astonish you, but they could also provide new perspectives on our place in the universe. Let us dive deep into a world of imagination and science, where the unknown lingers in the shadows, leaving scientists both awestruck and perplexed. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. According to scientists, the Big Bang refers to the moment when the universe became unimaginably hot and dense, expanding rapidly to form all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning in galaxies moving away from a central point. But why did this happen? Was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and uniform, essentially like a colossal vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that drove the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything that would follow. In a fraction of a second, space expanded at astonishing rates until the expansion slowed and the energy transformed into particles, forces, and the building blocks of the universe. But what was the nature of this energy? Why did it suddenly trigger the creation of the universe? And why did it stop? Scientists theorize that this rapid expansion created patches of the universe, each undergoing its own Big Bang. Imagine a fabric expanding endlessly, with tiny air bubbles forming, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests there are potentially infinite Big Bangs and a limitless number of universes. Our universe is just one of many. This vast, mind-bending reality challenges our understanding of the cosmos and leaves us wondering, what else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least as we currently understand it. Even if we strip the universe of all energy, particles, and radiation, it would not truly be empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an intricate tapestry of something. Even in its emptiest state, the universe generates new forms of energy. Scientists find this puzzling, as it suggests true nothingness may be impossible within our cosmic framework. Space itself has properties, laws, and constants that prevent it from being completely empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy. Even so, quantum fields and cosmic constants would still exist, implying that this nothingness has properties. For example, there is a concept called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still appear and disappear, creating a ghostly hum of activity even in what should be empty space. This challenges our idea of a true void and suggests that, yes, even before the Big Bang, there was something. Scientists continue to explore this, and one of the most intriguing theories in modern cosmology is eternal inflation. If inflation could create our universe, it is possible that it could continue endlessly. Brian Cox describes a vast, inflationary multiverse where universes are continuously created and expand. Imagine each Big Bang as a spark igniting another universe, while inflation occurs in other regions, creating countless different universes. This process could, in theory, happen infinitely. This idea of colossal universes birthing others leads to the fascinating concept of a fractal universe, where each new universe might generate its own Big Bang. Each universe exists as an independent space, unaffected by the others, within the rapid expansion of space itself. For researchers, this theory is both thrilling and unsettling. It suggests an endless multiverse with no definitive beginning or end. Imagine our universe being just a speck in a vast cosmic tapestry, constantly creating and regenerating new universes. What if this is the true nature of reality? There is no before or after, but rather an eternal pattern of universes forming. Our understanding of nothingness shifts when we consider quantum field theory. This theory suggests that the universe is not a collection of matter floating in space, but rather a complex network of energy fields permeating the cosmos. These fields interact to create everything we observe. Even when fields are at their lowest energy level, known as a vacuum state, they are still active. Particles can appear and disappear in these fields, temporarily borrowing energy before returning it. This behavior leads to the concept of virtual particles, entities that briefly exist and then vanish, leaving behind only a faint trace of their presence. The idea of virtual particles challenges the notion of a true void. Even an empty universe, stripped of matter, radiation, and energy, would not be nothing. Quantum fields would remain active, sometimes creating fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't adhere to our idea of emptiness. These fields and forces persist, filling the universe with subtle energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields can create particles and particles form matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy, a mysterious force currently driving the accelerated expansion of our universe, adds another layer to this question. Did dark energy exist before the Big Bang? Some theories suggest that dark energy today is a remnant of an energy field from before our universe's formation. The properties of dark energy seem to hint at a powerful, enigmatic force that might have existed in some form prior to the Big Bang. Certain hypotheses propose that a stronger version of dark energy may have fueled the inflationary phase, causing rapid expansion. The presence of dark energy suggests that, even if our universe were emptied of all matter and radiation, this force would continue shaping the very fabric of space-time. This idea brings up a profound question. If dark energy existed before the Big Bang, could it have created the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true origin of everything we know? As we explore this possibility, we confront the potential of dark energy not just as a force shaping our universe, but as a key to unlocking the secrets of the multiverse itself. Another theory offering an alternative to the Big Bang as a definitive beginning is cyclic cosmology. This theory proposes that the universe undergoes massive cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event, but part of an eternal cycle where universes collapse and then regenerate in a new form. Cyclic cosmology suggests that our universe may have been reborn from the remnants of a previous universe. The process of compression and expansion in a cyclical pattern implies there was never a true beginning, only an infinite sequence of universes emerging, creating, and renewing themselves repeatedly. This theory raises profound questions about time itself. If cyclic cosmology is correct, time may not progress linearly, but instead loop back on itself in an eternal rhythm. If this is the case, what existed before the Big Bang may simply have been another version of the universe, one that collapsed only to give rise to the universe we now inhabit. For scientists, cyclic cosmology is both alluring and challenging, as it suggests a reality where the concepts of beginning and end lose their meaning. Instead, existence becomes a perpetual cycle without a clear origin.